All of the cables that we have covered so far, such as twisted pair cable and coaxial cable, are vulnerable to interference and wiretapping. Proper shielding can minimize interference, but it cannot be completely avoided. These two issues have been resolved in fiber optic. A fiber optic cable is a thin glass table surrounded by a plastic coating. This picture shows the main elements of a fiber optic cable. The fire-resistant yarn and a strong plastic jacket protect the glass core from bending, heat, and stress. Unlike twisted pair and coaxial cable that transmit data as an electrical voltage, fiber optic uses light pulses as a carrier signal. To transmit data, a light source such as a photodiode is placed at the transmitting end and quickly switched on and off to produce light pulses. These light pulses travel down the glass cable and are detected by an optic sensor called a photoreceptor on the receiving end. The light source can be either a simple and an inexpensive LED or a more complex laser. The laser is much more expensive than the LED, and it can produce much higher data transmission rates. Fiber optic cable is capable of transmitting data at more than 100 gigabit per second over several kilometers. Because fiber optic cable transmits non-conducting photons through a glass medium, it is impossible to wiretap. Also, because fiber optic works with light, it is immune to electromagnetic interference and noise. Despite all advantages, fiber optic has two big disadvantages. First, light pulses can only travel in one direction, and in order to support a two-way transmission, two fiber optic cables are necessary. For this reason, most fiber optic cables are sold with two individual strands of fiber bundled into a single package, as shown in this picture. The other disadvantage is its high cost.